and another 15 units. So, so what do we use radioactive isotope for? We use radioactive isotope. We can use it in a clinical situation. For example, we can use radioactive isotope to detect cancer, a tumor. You see that this is the thyroid gland in the neck, and when we use radioactive iodine to label the thyroid gland, you see that there's some part missing here, because the tumor does not take up the radioactive iodine. Then the doctor can tell that, okay, you have a tumor in your thyroid gland. And then we can also use radioactive isotope in PET scan. PET scan stands for positron emission tomography. So what happens is that the doctor inject the radioactive isotope into your bloodstream, and then the bloodstream will go to your of course the radioactive isotope will go to your brain, and then when they scan your brain, the more active part of your brain will become red or yellow. The less active part of the brain will become blue. So it can tell the doctor that, okay, which part of your brain is functioning, or which part of your brain has the stroke that killed the brain tissue, that's why it's not active. And we can also use radiation to literally kill the cancer cell. How does it work? Is that, for example, this is your brain. This is your brain. And then you have a tumor here. Let's say you have a tumor here. If you shoot a very strong radiation, what happens is that you shoot a strong radiation here. This will kill all the cells along this line, including the healthy cell. You will kill the tumor cell along this line, but also you will kill the healthy cell, which is something that we don't want to do it, right? So what happens is that doctor figure out we can tune down the power of this radiation, but we shoot multiple radiation at the same time, so that each of these radiation, they're weak. And when they're weak, they do not kill the healthy cell, and they also do not kill the cancer cell. But the summation, adding all these weak radiation together at this point, then you will kill the cancer cell there. So only the point that they cross each other, they will have high enough energy to kill the cancer cell. So in this case, radiation helps to helps doctor to kill cancer. Now, electron. So normally for an atom, the number of proton and number of electron, they are the same when they are neutral, when they are not doing anything. And electron, they move around the atom in something called orbit. Orbit, or you can call it electron shell. They have different energy level or different electron shell. The first electron shell or first orbit, it can only contain 2 electrons. And then after that, the second electron shell or the third electron shell, they can hold 8 electrons. We call that octet group because it can maximally hold 8 electrons. Remember, the number of electrons on the electron shell, they are the number of electrons are the one that determine the chemical properties. They're the one that form the bond, that break the bond. That's why we need to learn about the electron shell, because it tells you the chemical reaction later on. So we give an example. Hydrogen, the mass number is 1. That means it has 1 proton. It doesn't have any electron. 1 atomic number. That means it has 1 proton only. So in here you have, in the nucleus, you have 1 proton and you have 1 electron. So this is the neutral hydrogen atom. For carbon, the mass number is 12. That means it has 6 carbon atoms, 6 atoms and 6 neutrons. and then you have 6 proton here. I mean 6 proton and 6 neutron here, and you have 6 proton here. So because you have 6 proton, you also need to have 6 electrons to balance the positive charge. So the first electron shell, or the first orbit, you have 2 electrons. Second orbit, you have 4 electrons. Nitrogen atomic number is 7. That means it has 7 proton. The mass number is 14. That means it has 7 more neutrons. Because of that, you need to have 7 electrons here. 2 in the first electron shell, and then 5 in the second electron shell. And oxygen atomic number is 8. The mass number is 16. I want to emphasize one thing. The mass number is not necessarily the double of the atomic number. In all these examples, we see that it's like, all of this is like the double. But it's not necessary. Remember, in an isotope, it's not like this. So we have 2 electrons in the first electron shell, and then we have 6 electrons in the second electron shell. In other words, you can look at this. Does it fulfill octet rule? That means, does it have 8 electrons in the outermost shell? No, it only has 6. This one, does it fulfill octet rule? No, it only has 5 electrons in the outermost shell. So most of these, they have not fulfilled the octet rule first. When they are not fulfilling the octet rule, that means when they do not have 8 electrons in the outermost shell, or in this case, hydrogen, when it does not have 2 electrons in the first electron shell, that means the atom, that means the element here, they are not stable. Similarly, phosphorus. Now you can see that the mass number is 31, but the atomic number is 15. So it is not really double. We have 16 neutrons, but 15 protons in the phosphorus. You can see that first electron shell, you have 2 electrons. Second electron shell, you have 8 electrons. But the outermost electron shell, the third one, you only have 1, 2, 3, 4, 5 electrons. So phosphorus in the element form is also not fulfilled by the octet rule. Sulfur in this case it has 16 proton and 16 neutron. In this case, you can see that 1, 2, 3, 4, 5, 6. It has 6 outermost electrons. So it is still not fulfilling the octet rule. This is just a summary. Now, we talk about element. What about molecule and compound? Molecule, by definition, is when you have 2 or more same element bond together. An example is oxygen gas. Oxygen gas O2, we call it molecule. Compound is when you have 2 or more different elements bond together. It is different. For example, H2O. Another example, you can call it NaCl, which is our table salt. So what happened in here is that there's a mistake that we make every day. We always like to call water. Water is a water molecule. Water molecule. You have never heard people say that water compound. So for the strict scientific definition, we should call it water compound instead of water molecule. But in our everyday life, we just call it water molecule. But in the exam, make sure that you know the definition of the 2 scientific definition. So this is important. This one, the last bullet point, is important because it summarizes everything we will talk about for the rest of the lecture. Is that what is a chemical reaction? Chemical reaction is basically you either break a bond or form a bond. Then what is a bond? Bond is basically formed by electron. So when 2 atoms, you have the outermost electron. When 2 outermost electrons from 2 different atoms, they interact with each other, then you form a bond. So chemical reaction is either forming a bond or breaking a bond. So the first type of bond we want to talk about is ionic bond. ionic bond is a complete transfer of electron from one another. It gives you an example, sodium and chloride. It tells you that sodium with 1 electron in outermost shell become donor. Chloride has a 7 electron shell become receiver. Let me show you the picture. It should be easier. Okay. In here, let me tell you. Oh, okay. Let's end here first. Let's end here.